So the next thing to talk about is risk in capital budgeting. There's two ways to account for it. One is you can adjust the discount rate by adding a risk premium. So if you want to make 8% on your investment, but this one's more risky, we may add a risk premium on there and say, well, we've got to make 5% more because of the risk involved here, so we need to make 13% on this investment. A second way is to calculate the net present value under multiple scenarios and assign probabilities to each of those scenarios and calculate an expected NPV. You can do this using risk formulas that are found in Chapter 2. Another final way to do it is to do sensitivity analysis, and this is what I do a lot. And this is just once you have your Excel spreadsheet set up, we've designed them so that you have all your assumptions in those pale green cells. So then you can start to change your assumptions, change the green cells, and start to see what that does to your results. And I think that's a really nice way of incorporating risk into your capital budgeting. The final thing that Chapter 11 goes over is feasibility. And this is a very simple concept. The idea is that in order for an investment to be feasible, when you have to have the time and the other resources necessary to do it. So if an investment's profitable, you can make money. That's net present value greater than 0. But if it's feasible, it's not whether or not you can make money on it, but whether you have the initial investment, if you have negative net cash flows in certain years, you have additional funds to service and pay for those negative net cash flows. So feasibility is different than is it profitable. In general, you solve for what you know to see if it's possible. For example, if you can spend $600 a month on a loan payment, as long as the estimated amount is lower than $600, it's feasible. You can also solve for the present value of a $600 payment, and that would say, since that's what you can pay, and that present value would be the most that you could buy it for. So you just solve for what you know and compare it to your situation. For example, if the present value of your payments were $30,000, then you could only afford a $30,000 vehicle. So if the vehicle was $28,000, it would be feasible, but if it was $36,000, it wouldn't. So now we're going to go over the annual annuity equivalent, and this comes into play when you're purchasing items with different lives. Used equipment may cost less than new equipment, but you can use it for fewer years. So how do you compare those two things? One option is to repeat the investment multiple times, so each investment has the same number of years. I don't like this though, because you can get a lot of years very quickly. Like if one was 5 and one was 6, it's going to require a 30-year scenario for both of them to be able to compare. The other way is to find an equivalent amount per year, and that's the annual annuity equivalent, and then you just choose the one with the lowest cost per year. So step 1 is find the annual net cash flows for each option. That's the down payment, salvage value, loan payments, anything else. So find the net cash flow. The step 2 is to use that net cash flow to find the net present value. In this case, since we're talking about cost, because it's the cost of owning the equipment, the net present value is really the net present cost. And then we use that net present value as our present value, and we solve for the payment to get an annual cost per year. And then we compare those for each option, and we'll choose the one with the lowest. There's a handout that goes over an example for this, and that's what we're going to go through right now. So the example shows choosing between 2 drills, a used one and a new one. The used drill is going to last 10 years, and the new drill will last 15 years, and there's some extra repair costs for the used drill. So the first thing we did is find our net cash flows over the years, and you can see the used drill, they go up to 10 years because we have it for 10 years. The new drill goes clear up to 15. In the final year, we have a positive amount because that's the salvage value, what we can sell it for. And you can see that the used drill, the net cash flows get smaller in years 8 and 9, and that's because we've paid off the loan, and so we just have to have the extra repair costs. The new drill, we have stable amounts up through years 10, because that's how many years we've financed it over, and then no cash flows years 11 to 14, and then the salvage value in the final year. So we have our net cash flows, and step 2 is to find the net present value for each using a 10% discount rate. So you should go ahead and do that and press pause while you have time to put it into your calculator. And the answers are that the net present value for the used drill is $7,609.86. For the new drill is $10,559.13. So the new drill costs more, but we also have it for 5 more years, so is that worth it? And so we are going to calculate the annual annuity equivalent by solving for the payment. So we have our net present value, which is the present value, and so we need to find the annual annuity equivalent by solving here. And so you can pause this and go ahead and fill this in and solve it. And here's the information that you already knew. You knew the used drill was for 10 years, the new one was for 15. Our discount rate was 10% for both options. Our present values, the net present value you found in step 2 above. The future value is 0, and you're solving for the payment, which is going to be your annual annuity equivalent. When we do that, the used drill is less $1,238.47 versus the new drill, which is $1,388.25. And so you're going to choose the used drill because it has a lower cost per year.